We live in the age of satellites. In 2026, there are over 8,000 active satellites orbiting Earth, more than at any time in history. They connect our phones, guide our cars, predict our weather, and watch over our planet. But 2026 isn't just about quality. This year, we've launched the most powerful satellites ever built. Satellites with antennas the size of tennis courts. Quality is shifting from numbers to pure capability. Satellites that communicate with lasers at speeds that would have seemed like science fiction a decade ago. Satellites that think for themselves using artificial intelligence. This is the story of the strongest and latest satellites of 2026. It all started in 1957 with Sputnik, a simple radio transmitter the size of a beach ball. Today we have satellites the size of buses. Constellations of thousands and technology that our ancestors couldn't have imagined. The satellite revolution is driven by three things: cheaper launches, miniaturized electronics, and insatiable demand for data. In 2026, we're seeing the fruits of that revolution: record-breaking performance, unprecedented capabilities, and satellites that are redefining what's possible in space. In this documentary, we'll explore the most powerful satellites launched in 2026, from Amazon's internet constellation to China's latest weather watcher, from India's AI-powered observer to America's next-gen GPS. This is the complete story of 2026's most impressive machines in orbit. Join us as we explore the final frontier and the technology connecting our world. On February 12, 2026, a new chapter in space-based internet began. From Europe's spaceport in French Guiana, an Ariane 64 rocket roared to life. This was the most powerful version of Europe's new heavy-lift launcher. Its payload? 32 satellites for Amazon's Project Kuiper, now rebranded as Amazon Leo. This was the first of 18 planned launches to deploy a constellation of over 3,200 satellites. As David Cavalloles of Arianespace noted, this flight marked a major milestone for the European space sector. The numbers tell the story. This Ariane 64 variant is capable of lifting more than 20 metric tons into low Earth orbit, about twice the capacity of its smaller sibling. Protected by a 20-meter fairing, the satellites were deployed at an altitude of approximately 465 kilometers, just under 2 hours after liftoff. Amazon Leo aims to provide fast, reliable broadband internet to communities around the world, especially those currently lacking traditional access. Like Starlink, this constellation is designed to connect the unconnected, from remote villages to ships in the middle of the ocean. This launch, designated LE-01, was a major achievement for Europe. It proved that Ariane 6 could meet the demanding requirements of large-scale constellations. Ariane Group CEO Martin Sion highlighted that this success underscores the quality of European engineering and its strategic partners. 17 more launches are planned. Each mission will carry dozens of satellites, rapidly expanding the network's global reach. The race for space-based internet is on, and 2026 is the year where competition finally heats up on a global scale. Just days before the Amazon Leo launch, another milestone was achieved in low Earth orbit. On February 10, 2026, AST SpaceMobile announced the successful unfolding of its Bluebird 6 satellite. This is no ordinary communications satellite. It features the largest commercial communications array antenna ever deployed in low Earth orbit. Spanning approximately 2,400 square feet, Bluebird 6 represents a massive leap in space technology. CEO Abel Avelin calls it a result of world-class engineering ingenuity. 2,400 square feet. To put that in perspective, it's about the size of a tennis court. This massive phased array antenna enables Bluebird 6 to do something no other commercial satellite can: connect directly with standard unmodified smartphones on the ground. No special equipment, no bulky antennas, just regular phones connecting to space for voice, data, and video services everywhere. The massive antenna isn't just for show. It enables peak data speeds of up to 120 Mbps, fast enough for high-definition streaming and video calls. It delivers up to 10 times the bandwidth capacity of the earlier series. Its size enables highly precise beamforming, creating narrower, more focused coverage areas. This minimizes interference and maximizes network capacity. Bluebird 6 represents a revolution in how we manufacture innovative space technology at scale. AST SpaceMobile operates nearly 500,000 square feet of manufacturing facilities, employing a highly skilled workforce of nearly 1,800 people. The company is 95% vertically integrated, maintaining strict control over the entire process. This allows them to iterate quickly and maintain world-class quality. Able Avalon notes that they aren't just building satellites. They've cultivated a workforce capable of operating at the very frontier of aerospace. Bluebird 6 is just the beginning. AST SpaceMobile is on track to launch up to 60 satellites by the end of 2026, with launches planned every 1 to 2 months. The company has agreements with over 50 mobile operators globally, representing nearly 3 billion combined subscribers. Strategic partners include AT&T and Google. The vision is clear: global cellular broadband from space accessible by every unmodified smartphone on Earth. This is the future of connectivity. The largest commercial antenna in orbit is just the first step in a journey to connect every corner of our planet. Stay tuned for Part 4 as we look at China's weather giants.